Hello, my name is Hajime Sugiyama from Mitsubishi Electric, and I'm an Industrial IoT Evangelist. Today, I'd like to talk about the truths about Industry 4.0 and Industrial IoT, and actually do some review of a post-installation of IoT and what we learned through that experience. I just have a lot of buzzwords over here, like Industry 4.0, Society 5.0, Make in India, Cloud, Big Data, 5G. There's a lot of buzzwords. Lowering costs, saving energy all around the world. And then dream big, start small. At the end, it's always ROI. So why is this? Please, at a small scale. Because of the internet. Test. If there's a lot of good things about the internet, and we think the future is with robots. And the internet brings everybody together, flexible. Everybody's connected. But on the other hand, and I think the internet has a dark side to it. I think, which is we made mistakes. But at the end, we only made mistakes because we tried. Look at the Japanese manufacturers. Just everybody to start IoT, try with IoT. We're there to help in the past, and you learn a lot in our products how to. You only have to worry efficient about the Japanese competitors. Okay, I have a lot of other topics I'd like to continue sharing. You have to worry about the Huawei. I think that's all for China. And we're actually competing against companies like Apple or Google. And I'm sure we're going to have more competition in the future from Southeast Asia, from India, and from Africa. Why the global competition? Why the global competition? It's because it's right now so easy to sell a product over the world, produce a product and get it over the world. Everything's connected, all the web shops are connected. But global competition means it's going to be a price war. Everybody's going to fight for cost. The purchaser always is going to look for the most cost-efficient product, and that means if you're not strong in manufacturing, if you can't reduce your manufacturing costs, you're going to lose the war. And that's why a lot of companies and a lot of countries are putting effort into strengthening their manufacturing capabilities. What is Industry 4.0? I use this kind of slide to make it easy to understand. And this is what I think the future of manufacturing will look like. I'm going to use this example of a pink polo shirt in order to explain this. So in the future, you're going to go to a web shop like Amazon or eBay and say, okay, I want this pink pink polo shirt. You press a button and the order goes directly to the system. Then it figures out the material that you need to produce it. You need this cloth, and you also need the pink dye in order to dye it pink. This material comes from the suppliers on an automated guided vehicle with no driver. There's a full automated production line waiting for this. The robots pick up the t-shirt, they cut the clothes, they do the sewing, they dye it, and they automatically do the packaging with no humans involved. At the end of the line, a drone is waiting for it. It picks it up, and it brings it directly to your doorstep. This is Industry 4.0, and it's beautiful. I mean, it's made to order, meaning you have no waste. In a traditional factory, you have to purchase all these parts or the clothes or the dye up front, but you may not use it because there's nobody who wants that color. This way, you have no waste. You're only making what you're going to sell. Also, there's no room for mistake. Everything's automatic, there's no fax, there's no paper involved. And the robots are making it, so your quality is perfect. And I think this is how the future factory is going to look like, and what Industry 4.0 is trying to achieve. I think it's going to take some time, 10 years, 20 years, but eventually we'll get to this point. But you have to be careful. And so a lot of companies are getting excited. The presidents read a news article, they're excited. Okay, I want Industry 4.0, I want IoT. And they come asking us, okay, how do I put Industry 4.0 in my factory? But the first actual question you should ask yourself is, what is your goal? I mean, IoT Industry 4.0 is only a method. It's not your goal. Your goal should be improving your quality, reducing your manufacturing costs, reducing your lead time. That is the goal you need to achieve. Okay, you can say, let's just gather all the data we have and we'll figure it out later. But gathering data, just gathering data and finding out problems is impossible because there's so many data, and the data you're going to use depends on what you want to achieve. So you're going to have to, you end up throwing all away the data and finding out that you have to gather new data if you just gather data. So please be careful and always set a goal why you are implementing Industry 4.0 or IoT. The most important goal in manufacturing is to be lean and flexible. What I'm saying is, you can always spend a lot of money and make the perfect production line for your smartphone, say, okay. It's going to take some time. You're going to need to program all the robots. You're going to use AI, data analytics to find out when the machines go wrong and stop them before they create a failure product. But think about this. Here's an iPhone, and you make the total perfect production line for this. It's probably going to take you over 2 years to make this perfect. But in 2 years, you're probably not going to even make this phone. The new iPhone is going to be a foldable model. Maybe it's going to be on your watch. Maybe it's going to be in your glasses. Nobody wants a 2-year-old, 3-year-old old product. So your effort is wasted. In this case, it would probably even be better to use humans to make the product to have a quick release to the market. And you have to have a flexible production line. Everybody likes customized product, your own color, your own memory, your name engraved in it. So you have to have the capability to make multiple products on your production line. And that's why your line should be very, very flexible right now. So at the end, the final goal of manufacturing is not installing IoT. It's not installing Industry 4.0. It's making your production line lean and flexible. And if humans, conveyors, do the job better, then you should use them. Lean manufacturing is engraved in Japan's history. You see these words, the Toyota production method, Kanban, Kaizen, Pokayoke, Andon. They all come from Japan. Why is Japan so good at lean manufacturing? Why is it the mother of manufacturing? I think there's a historical background to this. It's because Japanese in Japan is expensive. We have very, very small land, so small island, so land is expensive, people is expensive, and also because we have no natural resources, energy and resources is expensive. But we had to fight with the world. When China evolved as the factory of the world, we had to compete with Chinese products. But we survived. And why did we survive? It's because we tried and tried and tried to find ways how to reduce costs. In the past, Japan, one worker cost 20 times of a Chinese. Right now, I think the ratio is closer to 1 to 3. And there's a lot of cases where it's actually cheaper to manufacture in Japan than a developing country. This is because we have refined our production processes and put our lean manufacturing concepts in, and they're working. So I think there's a lot of things that the Japan manufacturing community can teach to the world. Industry 4.0 and IoT is about bringing two worlds together. We're bringing together the IT world to the factory automation and OT world, operation technology world. But it's not so easy. These are totally two different worlds. I worked in a factory once, in an engine factory, but we're the guys that screw things, assemble things. The IT guys are the guys in front of a computer doing hacking, writing Python. It's totally different. And to bridge this gap is not so easy. There's a big barrier in there. So that's why we us as Mitsubishi Electric, tried to sit in between these two worlds to help communicate better. And we also have a lot of edge computing solutions to bridge these two worlds together and to make the factory able to use the cool technologies like data analytics, the cloud, big data, and AI. In the past, you only had to think about the factory, but the scope is going to expand. I talked about a phone. In the past, when you wanted to put a phone into mass production, you first design the phone, make a prototype, then you design the machines to make the phone. You built the machines and you went into mass production. And it took a lot of time. But right now, every year, you have to release a new phone. Meaning, you don't have the time to go through that traditional pathway. When you develop a phone right now, you have to simultaneously think of how I'm going to build the machine, what machine, engineer the machine together, and also engineer the production process together. In order to do that, you have to connect the data with the engineering section to the production line, and that's what we say tagging into the engineering chain, connecting the engineering chain. You also have to connect the supply and delivery chain as well. Customers nowadays expect when you place an order to get next day delivery. So you have no time to take up a fax, to put in a paper order into the system, and then start production. So you have to connect the data throughout the supply chain as well. Not an easy job, but in order to survive competition, you're going to need to do this. One important thing we also think about when we put into Industry 4.0 IoT solution is to dream big, but start small. Meaning, of course, you should look at the future, all the possibilities you have with IT, but think, because at the end, it's ROI, it's return of investment. You can spend a lot of money investing in Industry 4.0, but if that investment cannot reduce your manufacturing costs, it's meaningless. Why did you put that effort in the first place if you can't reduce costs? So we always suggest have a big idea, but start small. Start with, for instance, a packaging cell. Connect the data here, use AI, use robotics, and see if you can reduce the cost there. If you can actually see the return on investment, then you can expand. You can copy the line, or also expand throughout the line, tackling other products. But only if you can see that the small part works. So it's very important, dream big, start small, and at the end, it's always ROI. One more thing is keeping it easy. IT, IoT, it's a totally different world from manufacturing. The code we're using is totally different. But at the end, who's going to use this technology? It's going to be the staff, the workers on the factory floor. And if they cannot use this technology, if it's too difficult for them, this is also useless. And that's why when we put installation inside, we say, okay, it has to be at a touch of a button. You just touch a button, the AI tells you the answer. You have to keep it simple, or they're not going to use it, or they can't use. I want to go through a case study of how we implemented IoT into our factories and robots into our factories, and what we learned for it. We'll first start with a no-fuse breaker production line that we had in Sugiyama. The issue with this production line is that it had what we call these little short stops. A robot could not pick up a part properly, so the production line would stop. Or too much parts got crammed into the production line, so it stopped. And the production line would stop several times every day. So in order to improve productivity, we want to reduce the amounts of short stops. But the problem is, at the same time, we need to do production. So every time there's a short stop in the production line, a worker would go there, take out the part, and restart the line. If he didn't do that in a fast manner, the line would be stopped and our productivity will go down. So the first effort was always to resume the production line. But in order to really improve this line, we said, okay, we have to find out where the short stops are happening and which production line and which process and when making which product. if we don't find that out, we're not going to be able to improve the efficiency of the production line. So we did the old way. We had the error data information in our machines, so we went to the HMI, put it in a CF card, took all those 20 CF cards to our PC, put an Excel file, and made a graph. Okay, here's where the production line should be stopping the most. We made an analysis, but then we find out, okay, we don't have enough data. We missed some data, or the sorting is not correct. There's no correct timestamps on it, so we can't tag it in together. Okay, we've done this for 2 weeks, but then we say, let's gather them again because we don't have sufficient data. We go through the process again, another 2 weeks. At the end, again, we don't have enough data. But, okay, we say, we can't waste another 2 weeks, so let's just guess. This was not good for us, and we felt our Kaizen speed was very, very slow. So we said, we have to fix this, and let's try to use IoT to solve this. So what we wanted to do is to be able to monitor and capture the short stops in real time. In order to gather real time, we understood that as long as we have a lot of manual work in there, we cannot gather the data in real time because people, they don't transmit data to our systems. So let's automate as much as possible, and let's put a lot of robots in. Then we will be able to collect the data in real time. I talked about when you use IoT, you should have a goal. We had a simple goal, was to make this screen. How many short stops occurred, which process, and which products. If we could find the point that was stopping the most, then we can improve it and go to the next part where a lot of short stop occurs. So we wanted to keep it simple, and we said, let's collect data so we can make this chart. This is the actual production line. We make 30 different products, and there's 20 processes in this production line. It's a fully automated, beautiful line with robots and machinery. We collect the data through a PLC and send it through the network, and we transmit via wireless LAN to our main PC. And the data analyzed in real time, so the line worker can always see where the key point problems are in. This is the actual screen that our factory staff see, and they can immediately pinpoint the product and process. Also, more important, they can find the reason why these things happened. And they're constantly looking at this and trying to improve where we have a lot of short stops. You can see the results. Short stops minus 75%, operation efficiency improved 50%. This is because we were able to shorten what we call the Kaizen cycle. In the past, in order to do Kaizen, we had to wait 2 weeks or a month. In this case, everything is real time. We immediately see the problem without waiting 2 weeks, and we can fix it. Then we can go to the next one, speeding up the Kaizen cycle, and it contributed to our operation efficiency. It was a beautiful experience, so we said, let's go to the next production line and even roll it out further. So we have a magnetic contactor factory where we have to make 14,000 variations of products. It was very difficult us to manage this while keeping the quality. So let's put this more robots, let's do more automation there. What's interesting about this story, and I'll tell you the reason later, is we stopped it and we're throwing away the lines because we found out that actually introducing humans back into the process was more efficient. There's a lot of beauty about IoT and automation. These production lines, they receive the work instructions, they scan a barcode, and the machine is automatically set up. You have continuous quality control, meaning because you're testing real time and you're saving the data real time, if there's a problem, you can immediately stop the process. You're recording all test data and keeping traceability, So you have a market failure, you can go back and pinpoint this product was made by this person at this date at this time. This is a chart of the actual production line. It's a pretty big line. It's 35 meters going this way to this way, so it's about 70 meters. It took up a lot of space. You see there's a lot of space. This is the main production line where they're making the product, and the circles are the robots, but there's a lot of machinery on the backside of the production line. This is because we were making multiple different kinds of products. We needed different feeders to feed the machines automatically different parts. It was very efficient, but we had a big problem with this production line. One was that one stop in the entire production line stopped the whole production line. So if we had a short stop here, it couldn't pick up a part, all the 100 products on the production line stopped. This was a big issue. Our solution to this was introducing what we call cell production. You can see the cell production over here. It's a combination of a human worker working with the robots in a small cell. The human worker is doing three things. He's kitting the parts together, providing the necessary parts to the robots. The second one is to set up the machine, so he scans the order sheet and set up the machine. And third, he does final inspection. Because we don't have the feeders, it saves a lot of space. And it also has a lot of more benefits to this. See, we can fit 6 cells into the same space of one production line. This is good because it means we can produce 6 different products at the same time. So we're more mass customization possible. The other thing is, even if one production line stops, there are 5 are still operating. So at the end, we saw the results. Putting people and robots in the right place was better. And we tore down the 2 big production lines, and we moved everything to cell production. But you can see the result. Productivity 30% up, operating rate 60% up, and the number of processes in the area went down. Robotics automation was beautiful, but at the end, we found out that migrating people back into the process made us more lean and made us more flexible and made us more efficient. So always robots are not the answers. I think, there's room for robots, and there's room for humans, and there's room for dedicated machines. You just have to think about the cost balance and efficiency. I mean, everybody talks about robots versus humans, but I think the future of manufacturing will be robots and humans. Okay, that's the end of my presentation. Just some few keynotes. IoT is not your goal. Lowering costs, saving energy is. Dream big, start small. At the end, it's always ROI, so please, at a small scale, test if you can get that ROI. And we think the future is with robots and humans, being lean and flexible. And I think that's all. I think we made mistakes, but at the end, we only made mistakes because we tried. So I suggest everybody to start IoT, try with IoT. We're there to help you, and you learn a lot of how to be even more efficient with your manufacturing processes. Okay, I have a lot of other topics I'd like to continue sharing to you, but I think that's all for today. Thank you very much for listening. Bye.